Well, good morning, class. Welcome. Today we are looking at systems of equations and multiple representations. So when I say multiple representations, I'm talking about graphs, tables, equations, and situations. So what's going to happen is I'm going to describe a situation, and then from that we're going to create multiple representations that allow us to find a solution to a system. So let's start by reading this problem. So please take out your notebook and label this section 6.2.3. Today is the 15th of March. So March 15th, 6.2.3. The Alpine Music Club is going on its annual music trip. The members of the club are yodelers, and they like to play the xylophone. So I'll just be real clear. The reason why we're using yodelers and the xylophone is they're already kind of setting the stage for moving from this situation to an XY representation. So yodelers are probably going to be tagged with Y's, xylophones probably going to be tagged with X's. This year they are taking their xylophones on a gondola to give a performance at the top of Mount Monk. The gondola conductor charges $2 for each yodeler and $1 for each xylophone. So the yodelers are the people, right? The xylophones are some instruments that they play in addition to the yodeling. So $2 for each yodeler, and they can bring on a xylophone for $1 per xylophone. It costs $40 for the entire club, including the xylophones, to ride the gondola. Another piece of information, 2 yodelers can and do share a xylophone. So the number of yodelers on the gondola is twice the number of xylophones. Question, how many yodelers and how many xylophones are on the gondola? How many yodelers, that's Y, and how many xylophones, that's X, are on the gondola? So one of the first things we want to do is very clearly identify what our variables are for this situation. We have X and Y, and we are going to, I think, quite naturally say, and we'll write this down, let X be the number of xylophones. And we're also going to say let Y be the number of yodelers. Xylophones? Okay, so this is important because now every single time I write down X, I know exactly what it is. X is a count, it's how many xylophones I have, and Y is a count, it's how many yodelers I have. Now there's 2 equations that are available here, right? One of them involves cost, and the other one involves this ratio of xylophones to yodelers. So the first one, the cost. The gondola conductor charges $2 for every single yodeler. So if I was to say, then if Y is the number of yodelers, 2Y is how much money I'm being charged for the yodelers to ride. So for example, if I had 10 yodelers, that would cost $20, right? 2 times 10 is $20. If I had 4 yodelers, it would cost $8 for them to get on, because every single yodeler gets charged $2. The other equation I have is that every single xylophone costs $1. So I can say plus 1 times X, or I can just say X, right? But 1X or just X represents the amount of money I'm paying for the xylophones. Now, if I take the money that it costs for the yodelers plus the money it costs for the xylophones, I get a total amount of $40. So this is one equation, in this system of equations. This equation, y equals 1x, 2y plus 1x is 40, is representing the cost equation. Now, let's take a look at this equation, because there's lots of solutions to this equation. So I'm going to ignore everything else about this problem right now, but I'll do this. I could have, for example, 20 yodelers and no xylophones. That is a solution to this equation. So if I'm looking at just this equation alone, I could have 0 xylophones and 20 yodelers. If that's what I had, it would completely be a solution, because 2 times 20 is $40, and $40 plus $0 is still $40. That's a solution. I could have also, I could say that I have 10 yodelers. 2 times 10 is 20. If I needed to get to $20, if I've got 10 yodelers, that's just $20. I would have to have 20 xylophones. So that is a solution to this equation. It might be easier, if I want to come up with a lot of solutions to this equation, to rewrite it so that y is alone. So I can rewrite this equation as, well, I guess I'd take away x first. So I could say that 2y is equal to the opposite of x, so negative x plus 40. And what I did there is I just subtracted x from each side. I can now take and divide every single term by 2. So that would give me the equation y is equal to negative 1/2 x plus 20. So this equation represents all the possible ways that I can have yodelers and xylophones and still have it add up to $40. So that messed it up. But if I wanted to, let me close this web browser. If I wanted to, I could graph just that relationship. And that relationship is 2y plus x has to be $40. Enter. Now, you see nothing here, but if I zoom out, we can quickly get to where, I can see stuff here, right? I can see things. And in fact, look at the things I can see. Y is the number of yodelers. And if I had 20 yodelers, that will allow for absolutely no xylophones, because 2 times y is $40. So 2 times y is 40. And over here at 40, because every single xylophone costs $1, this is the situation where I've got no yodelers and 40 xylophones. And that costs $40 as well. Also, what I did was we solved this equation for y. We got y alone, and when we did that, we wrote down y is equal to negative 1/2 times x plus 20. But appreciate the fact that this equation is exactly the same. So I can have this one, right? 2y plus x is 40, but that's the same as y is equal to negative 1/2 x plus 20. They're the same exact information. Both of them are ways of writing the same relationship down. Let's go back to our notebook. So at this point, we have one of our 2 equations, and we've graphed it, right? We can look at that graph, and we can see it in Desmos. But there's another thing going on here, and we're going to come up with that other equation, and this is the other equation. I'll highlight this in green. It says 2 yodelers can share a xylophone. Okay, 2 yodelers can share a xylophone. So the number of yodelers on the gondola is twice the number of xylophones. The number of yodelers is twice the number of xylophones. Look, the number of yodelers is twice the number of xylophones. Right? Because of our let statement, x is the number of xylophones, y is the number of yodelers. We have this secondary equation from the information that's in red. This equation says that y is twice x. Y is the number of yodelers. So this equation also says the number of yodelers is twice the number of xylophones. Now, that equation has lots of solutions as well, right? Tons of solutions. In fact, if I wanted to, I'll look at another table of values here. For example, on this equation, I could say, let me pick an x value. If x is 0, then y would have to be 0. If x was 1, y would have to be 2. If x was 10, y would have to be 20. If x was 20, y would have to be 40, right? So all these values, if x was 30, y would have to be 60. All of these values fit this relationship that y must be twice the size of x. So in order to solve this problem, what we need to do is figure out when these two equations, this equation and this equation, come together. Where do those two lines meet? So let's go back to Desmos for a moment. So back in Desmos, here we go. Back in Desmos, we can see that this top one is y is equal to 2x plus 40. I'm going to get rid of this y equals version of that. And let's type in our second equation. Our second equation is the number of yodelers is twice the number of xylophones. Okay, so now we have two equations, right? The red one is when I get on the gondola, it costs $40. Every single yodeler costs $2, and every single xylophone costs $1. And the other equation I have is that the number of yodelers is twice the number of xylophones. Now, there's only one place on the Cartesian coordinate plane when both of those come together. And you can see it, it's right here. And if I hover and click it, it happens at 8:16. When I have exactly 8 xylophones and 16 yodelers, both equations are true at that moment. So the idea here is when we're writing a system of equations and we're solving a system of equations, we're trying to find the location of something that makes two things true at the same time. This is the one and only point where the number of xylophones, or the number of yodelers, is twice the number of xylophones, right? The number of yodelers, y, is twice the number of xylophones, and $2 per each yodeler, $1 for each xylophone, it equals $40. Okay, so now let's go back, and now that we can see this representation, right, we can see this graphical representation of this problem, let's go back and solve this system of equations using the techniques that we've been discussing in class so far. So if I'm back here and I want to solve this system of equations, let's write them down again. So I'm going to write down y is equal to, I'm sorry, not y, 2y plus x is equal to $40. And the other equation is y is equal to twice x. So there you can see the information from this system. How have we been solving it? Well, when I look at it, I can see the second equation is clearly telling me, hey, y is the same thing as twice x. So one of our techniques we've been using is substitution. And if I look closely at it, I can say, look, that value of y, that's 2x, I can take it and I can put it up into the top equation. I can place 2x right there because y is the same thing as 2x. So how I might solve this system is to rewrite the second equation using substitution. I might say 2 times y, playing the part of y is 2x, plus x is 40. Okay, when I solve that, what do I get next? Well, 2 times 2x is going to be 4x. 4x plus another x is 40. That means 5x is 40. And if I take, oh, Robert, you're not doing that. 40 divided by 5. If I take 40 and divide both sides by 5, on this side I get x, and on this side, yeah, I use my calculator. I'm not ashamed of it. I get that x is 8. So x is 8 is the number of xylophones. I've got 8 xylophones. And to figure out the number of yodelers, and remember, we know that the number of yodelers is twice the number of xylophones. So I'm just going to say yodelers is 2 times what I find for x. But we know that x is now 8. So yodelers is 2 times x, which is 16. The solution to this system is I have 8 xylophones and 16 yodelers. And I can display that as an ordered pair. And because of the context, I probably should write out the system. I should write out the sentence, rather, that we have 8 xylophones and 16 yodelers this year on the trip. That's what we have. So, what do we have here? We have a situation, and the situation gave rise to two equations. We identified what our x value and our y value meant. We wrote down two equations, and then once we had that, we could solve that system here using substitution. And remember, we can go back and we can also view, Desmos, we can also view what that system looks like on a graph, right? Here's the first equation, here's the second. They meet at 8:16. There are 8 yodelers. There are 8 xylophones, X xylophones, and 16 yodelers. All right, that's all that I wanted to look at today. You're going to be practicing some instances where you're going to have to write equations given a situation, write equations given a situation, and you're going to have to solve systems of equations using substitution and the equal values method.